What is up? Daniel here with the Virtual Robotics Studio, and we are back. We're now ready to start programming. So of course we got the robot on the ground. We've got a battery in, got it turned on so it's booted up. Remember, it takes a minute or so after you power it up before things can start to be fully booted and connected to. So we're going to start today with autonomous programming. There's two different periods during an FRC match. The first 15 seconds is autonomous. That means all of the movement has to be pre-programmed for the robot. So we're going to write that program in this video. The next video then will cover teleoperated, and that's when the drivers take over and we use the gamepad inputs to make the robot do stuff. So autonomous program incoming, but before we start, we're going to give another special thanks to Argosy for making this all possible, to First and Andymark for parts and support, and to Team 302, Lake Orion High School, for hosting our studio. All right, so first step on the computer. And if your robot is ever not working, this is the first thing to check. We're going to connect to the wireless network of the robot again. So you remember, it should remember it, but if you're in an area where you have other saved wireless networks, it's going to potentially connect to those first. So it looks like now I'm reconnected to that. Then look for the 2025 WPI Live VS code. There's a documentation which looks the same. But we need the VS code, and double click on that to open it up. And this is what we're going to be basically programming in. We'll write all of our program stuff in here. And the first thing that we're going to look for is there's the icon, which is like the WPI Live icon or their 2025 WPI Live icon. And if you hover over it, it'll say Open WPI Live Command Palette. And that is where all of the specific FRC stuff is going to live. So basically, this is VS Code, which is a Microsoft development environment that is, I think, free for use. And so you can write a lot of different programs for a lot of different things in VS Code, Visual Studio Code. But the add-on that WPI Live has is going to include all of the extra stuff that it needs to be able to find the robot, download to the robot, compile for the robot, to also have templates and example files that we can open up. So that's where sort of like anytime we're trying to get a robot-specific thing, we're going to look at that palette. If we're just doing save and stuff like that, save and open, that's just going to be the normal file menu. So the first thing we want to do is click on that WPI Live button, and it should pop up this thing in the middle. And we're going to create a new project. So if you start typing in the box, like I typed create, and now create a new project is the first thing there. So I'm going to click on that to select it. And that will take us to the WPI Live project creator page. And the very first box here is going to be select a project type, example, or template. So if you click on that, now back up at the top, we have two examples, template and example. Examples will be like short snippets of code. If there's like a sensor that you want to try to use, there might be an example for that sensor. If there's a specific thing that you want to try to do with the robot and there's an example for that, you can open that up, try to learn how it works. Then the templates are sort of like framework for the entire program that's going to work for your robot. So we're going to start with a template here. And then you can choose the language. So like I said, I think when we were setting everything up, Java and C++ are both in VS Code. So we're going to do Java, which is the second one here. And then it's asking for a project base. Now, there are two major ways we're doing it. On the bottom, you'll see like Romy XRP. That's for like little like test robots or little desktop robots that you can use the same software for. But at the top, there's two major categories. We have command robot and we have timed robot. And command robot is probably going to be the one that's more common amongst veteran teams that have been doing this for a while. Command robot is probably a little bit more powerful. And probably a better way to organize the code. Now, first example code and code, whatever documentation for that, are done in a command-based program. We're going to be doing a timed-based robot here. And the reason for that is this is a very simple robot. We're not doing a lot with it. And when you do a command-based program, in order to have some of the benefits of the command-based setup, there is some additional complexity as well. So for example, in command-based, there are going to be multiple files that you have to jump through to go to the right file. And knowing where things are and where things run from is a little bit not as obvious as the time-based robot. So we're going to do time-based robot that's going to all be in one file. And it's going to be very clear where everything goes. So again, if you're interested in command-based, you can still watch this and learn some of the logic behind it, but you can also follow first tutorial for the command-based setup. So we're going to choose timed robot here. And then this is a base folder to place the new project file into. So it's going to make a folder for this project, but you could have a folder of all of your programs. So if we select a new program, I'm just going to go to the desktop. I'll make a new folder here to put everything in. And this is going to be my 2025 FRC code folder, let's say. Obviously, you can name it whatever you want, but you should name it something that helps you understand what it is when you look at it again in 6 months from now. And then select that folder. Next one is going to be what name do you want to name this particular project. So this is 2025 Kitbot for me. And down here, this will create a folder inside that base folder project, which is what I wanted. Then you have to put your team number in. So mine was 2378. And this is going to basically configure it so it knows how to find your team's robot and download to it, and everything that it puts in the kind of like background files that we're not going to look at is going to be set up correctly. And you can either enable or not desktop support. It doesn't really matter. We're not going to be using it, but you can also use the option to turn it on or off later. But I guess let's just turn it on right now. Why not? And once you have all of that set, you can click Generate Project. And it's going to ask, OK, it's created. Would you like to open it? And we're going to say yes in the current window. If you have something else in this window and you have a second project that you're opening and you want to compare stuff, then you could do New Window instead. But I'll do Current Window. And as soon as you create a new project like this, the first thing that it's going to do is start building. So it's doing a build task. And you can see over here it's kind of thinking. Down here it says it's doing a build. This might take a while. Usually the first time it builds is the slowest, and then it gets faster because it doesn't have to redo everything that it's already done. If you get something like this that pops up, it says please reload the window. So sure, I'll reload the window. Why not? OK, and the build is still going on. You can see I'm like 0%. It's still configuring. And while that's doing its thing, we don't have to watch that. We can start looking at some of the code. So on the side here, if it's not open, you can click on kind of the two pieces of paper for the Explorer. And this is where all the files for the project are. And the good news is we don't care about pretty much any of them at all. We're going to go into SRC, which is short for source, and then Java. And these are the only files that we care about. And in fact, main.java is a file that you should not touch. This just basically does a main setup of things, and then we're never going to edit this file again. If I click on robot.java, this is where all of our code is going to get added. So everything we do is just going to be in this robot.java file. We don't care about any of the other files that are here. But there are like build specifications and all kinds of other things that are out here that got set up for us automatically that we don't have to work on. And let's run through what's in this robot.java file really quickly. And then we'll start doing we'll do an initial download to make sure everything works, and then we'll start setting up our code. So at the top, this is basically our imports. This is where anything we want to use on the robot, we want to import a library that tells the robot how to use that thing. So if we want to control something with a Spark Max, we're going to have to import Spark Max. If we want to, actually that's primarily the only thing we need to bring in. Oh yeah, if we want to use an Xbox controller or a gamepad, we have to bring in a gamepad library. I think we're also going to do a timer for auto mode. So we're going to do all of our imports here. Then where it says public class robot extends timed robot, basically everything inside this open curly brace all the way down until this final closed curly brace on the end is part of this class, our robot class. And the robot class is a timed robot. And timed robot is then a class that has other things set up for us. We don't have to worry about that, though. I'm not going to go too deep into the Java-specific things. All right? This area, we can then, so up at the top, we import the libraries that let us create, make things that we can use. Right? Then down here is where we're actually going to create specific versions of it. And right now, we have this sendable chooser that lets us pick between different auto modes. So we are going to edit that to add some more auto modes in, but that's built in for us. But in this area, we're going to be like, hey, here's the left drive motor. Here's the right drive motor. Here's the second left drive motor. Here's the second right drive motor. Here's the roller motor. We're going to add all of those things in there. And then in robot, this is kind of just some initial stuff, initialization stuff that will run kind of at the beginning of everything and let us get set up. So if there's anything we want to put there here, for example, we are creating our options, our auto mode options, and they'll show up on the dashboard. I'll show you how that works once we have this program downloaded. Scrolling down, we then have robot periodic. So again, we have an open and a close curly brace here. And the idea is anything in between those two curly braces is part of robot periodic. And robot periodic is a function that's called every 20 milliseconds, no matter what. So this will always be running over and over again as long as the robot is turned on. So we can put background code here that doesn't actually control the motors, but maybe pays attention to stuff. And we actually aren't going to put anything there for this robot, but that's its purpose. By the way, all of the green stuff, anything in this green text is a comment. So comments are just for people to read. They're for the people. The robot will ignore anything that's in green like this. And you can add comments anytime you want. There are two different ways. You can do // and now this is a comment. Or you can see the way they did it. If you have multi-lines, you can do /* and then */ to close it. So anything between a / and an asterisk / will close it. I think this extra asterisk doesn't actually do anything. That's just part of the comment already. So adding some of those in, we'll add some comments too as we go, but adding comments in can make it easier to remember what the code is supposed to do and to sort of track stuff down later. All right, autonomous init. We have some stuff inside autonomous init. This is checking to see which auto mode is selected. Autonomous init runs one time, and it runs one time only at the very start of auto mode. So for example, if we wanted to reset our timer, this is a good place to do it. If we want to find out which auto mode we should run, this is a good place to do it. Autonomous periodic then runs repeatedly over and over again as long as the robot is in autonomous mode. So for this is where we actually are going to write our code of like drive forward, spit out the coral, back up, whatever it's going to be is going to exist here. Teleop init runs one time at the very start of teleop mode. So when you switch into driver control mode or teleoperated mode, this will run one time. And then we have teleop periodic, which will run over and over again. So inside here where there's nothing, that's where we're going to put all of our driver control stuff. The robot can also be in a disabled state. So we have disabled init and disabled periodic. Same thing. One runs once. The other one runs as long as it's in that mode. And then we have test init and test periodic. So you can choose test mode and run different code during test init and test periodic. And then we actually have simulation as well. And I think this is because we did the checkbox. But simulation mode doesn't actually run on the robot. This will run on a simulator on the laptop itself. All right. So all the way back up to the top. And let's go ahead and download this program. So this is a blank program. Nothing's going to happen. But we want to send it to our robot and make sure that everything is working. So if you click on the little WPI live icon again, we get some options. And we're going to choose deploy robot code. So if you start typing deploy, it's going to show up. And if you click on deploy robot code, on the bottom, you're going to see it's going to go through a bunch of stuff. Building, executing. And really, we just want to wait until this is completely finished. And again, I think just like when we opened the program, that first build took a while. The first time we do this, it's going to take a little while, but it gets, I think, faster in subsequent runs, subsequent downloads, or deploys. So we're stuck at 68%, but that's OK. I have faith it will start moving. I still have faith. It's just, there we go. All right. And it's done. So it took me 50 seconds. Again, if your laptop is faster or slower, you might see slightly different numbers there. But you want to see build successful. That means it worked. And this Rio log that pops up is sort of our evidence that it's done completely. So I can close that, actually. Once that pops up, we can just close that window. We don't need it. But what I'm going to do now is go ahead and run the driver station software. So find FRC driver station. It did make a shortcut on your desktop when we installed it, and say yes. And this is the driver station software. We ran this when we were doing a test setup for everything. What's interesting is now we have green light for robot code because we just downloaded robot code. Granted, the code does nothing, but there it is. And this is the smart dashboard here. And when I was talking about we have different auto modes that we can choose from, right now we have a default auto and one called My Auto. We're going to change those around into other sorts of things or other names. But we have our options. So when you go out to the field, you would choose the option you want, and then the field itself will start the robot. But in our case, when we're testing it, we could go to autonomous mode and then enable the robot. Also, practice mode follows the pattern on the field. So here we could test just our auto modes, and that's what we're going to do mostly, and we can test just our teleoperated mode. But when you go out to the field for a real match, the robot goes through a long sequence of stuff. First, when you plug in and everything is powered up and you're connected, the robot's going to be disabled. And it's going to actually be an autonomous disabled. Then it's going to run auto mode. Then it's going to go back to disabled. Then it's going to go teleoperated mode, and then back to disabled. So sometimes it's a good idea to run practice mode at least once. What practice mode will do is it will do that same pattern, 15 seconds of auto mode, then back to disabled, then into teleoperated mode, 2 minutes and 15 seconds of teleoperated mode, then back to disabled. And sometimes you can have bugs in your code that create problems when you're switching from one mode to the other. Like maybe autonomous works fine on its own, but autonomous has some weird bug that doesn't let it stop, and you never get to teleoperated mode. The only way you're going to know that that could happen to you on the field is by doing practice mode. So once you have everything up and working, it's not a bad idea to run practice mode once or twice just to make sure things work. And if you're practicing and you want to go through the whole process so your drivers get in that rhythm, then you can run the auto mode. You can run basically all of practice mode. So it'll do the auto mode. Then your drivers have a timed 2 minutes and 15 seconds to score as many points as they can. You can also just do teleoperative mode and time it with a stopwatch as well. All right, so there's nothing really for us to do here. We can't really enable anything or disable anything because, I mean, you can go to autonomous and you can enable the robot, and it's not going to move because there's no code telling it to do anything. We can also go to practice mode, and you can see if I enable it. Basically, it was in disabled. So one more time. Basically, when we enable it, it goes to this disabled, and it's flashing yellow as it counts down. Then it goes to enabled, and you can see it's counting down the 15 seconds. And then when it gets to the end of 15 seconds, it'll go disabled and then start teleoperated. All right, let's get back to our code. Oh, one more thing before we go back to our code. Just so you know, you should, when you're running this, especially early on and you're not confident in what the robot is going to do, you should be ready to disable the robot very quickly. Of course, you can click on the button to disable it. That is the best way to do it if you're here. But also know that the space bar on the driver station will e-stop the robot. So if you just have to reach out and hit something quickly to make it stop moving, that will do that. But I think if you e-stop, you may have to close the driver station and reopen it and reboot the robot at the same time. Reboot the robot, then close and reopen the driver station, basically, to clear the e-stop. The e-stop is sort of like a hard, it should not turn back on until you verify that it's safe and go through the extra steps. All right, now let's go back to the code, and let's get started doing some coding. OK, so like I said, we are going to have a bunch of things that we need to import so that we can use them. And the import here is edu.wpi.first.wpilibj. And in this case, timed robot or sendable chooser or smart dashboard. And all of these libraries in Java exist in the same universe. So what I mean by that is we can't just be like add a motor, because how does it know, first of all, is it a sim motor? Is it a Neo motor? Is it a Kraken motor? There are lots of motors, and it could be any of them. Then also, it could be a motor that's not even related to first if you just said like motor. So that's what all of this extra lines of stuff do. It says, OK, like go to this place, edu.wpi.first.wpilibj, and get the motor that is in there, for example, or the timed robot that's in there. So we're always going to have a bunch of stuff that we have to type first, but that's just the unique differentiator for it. So I'm going to go underneath the lines of imports that are already there. I'm actually going to add one more line, and let's do a comment. Just so you know, the ones above this comment were already there. And I'm going to be like, we added the imports below this comment. So we know the stuff that we're adding versus the stuff that was already there. And there are a few different things that we want to add. The first thing is all 5 of our motors are controlled by a Spark Max motor controller. So let's start out by doing an import. And this one is going to actually be, because this is a rev device, we're not going to do EDU. We're going to have to do com dot, and it's going to be rev robotics. But as you can see, it's not showing up. So one of the things to note is as I'm typing import, for example, you see how it's showing up as an option here? This is the autocomplete that's showing up. And it's good to pay attention to the autocomplete because if I click this or hit tab, I think, or hit enter. Let's test that. Yeah, or enter. It will select the thing in autocomplete and finish the line for you. This eliminates typos and makes sure that you are trying to add something that actually exists or the program recognizes exists. So I recommend autocompleting often. Java is case sensitive. So if there are capital letters versus not capital letters, you have to be consistent with that. And what's next? It's got a red squiggly line underneath it. If it has the red squiggly, that means there is an error on this line of code. Don't worry about that if it's the line of code that you're working on. But for example, if I up here deleted something, that whole line is now a red squiggly because that is not typed correctly. Let's fix that though. All right, but we need to add rev. So you can see if I wanted to add edu.wpi.first, like it's here. It shows up as an option. But I want to add instead a rev robotics thing. And rev robotics library starts with com dot and then rev. And if I type rev, there is no rev on my autocomplete list. And the reason for that is because we have not imported into our project. We have not installed the library for that. So here under vendor deps, this is where it's going to show up if it exists for us to use. So we have WPI lib here, but we don't have the rev robotics library. So that's what we have to go and do next. And in order to do that, if we click this line here, we can do, I think it's manage vendor libraries. And if you choose manage vendor libraries, it's going to give us a few options. We can check for updates, which is cool. We can also install a new library in offline mode or in online mode. Online mode is easier. So that's what I'm going to show you how to do. That's how I always do it. But after you choose this, it's going to ask for a URL. We need to get a vendor URL to be able to paste in there. Then it can go out to the internet, get the stuff it needs, and put it where it needs to put it. All right, so we're going to need to switch back to a wireless network that lets you access the internet. Obviously, we can't do an online installation if we are not online. So I'm going to disconnect from my robot, reconnect to the guest network here. And then we'll need a web browser. And let's see, I always find this by doing rev lib. And I think either of the first two options work for us. I'm going to go to rev lib. So this is docs.revrobotics.com/rev lib. And on the left, there is installation. If you click on installation, then we can start. I guess let's click on Java here. Or we can just scroll down. So C++ and Java installation. If you scroll down past LabVIEW to C++ and Java installation, we have online installation. Basically, we do manage vendor libs, install new library online, and then we need this URL here to be pasted in. Now, if you click on this URL, one thing I noticed, I'm doing this like really, really soon after kickoff. And so I'll send Rev a note too. But you'll notice down here it says https:// blah, 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 rev lib 2025. That's what we want. If I click on this, though, you'll notice up here it says 2024. So don't click on it and then copy the URL. We're going to actually highlight this written line right here and copy that. So I'll do copy. Then we can jump back into our thing. It says enter the URL. So we'll paste it right in there. And then you just hit enter. And it's going to say it's recommended to run a build after you do this. Sure, works for me. And I got a build failed. That's OK, because I have this import line, which we never finished. So I would not expect the build to be successful right now. OK, after import, we now can type com.rev. And look at that. Rev Robotics shows up as an option. You can also see revlib is showing up here under vendor deps. So that's perfect. So we're going to do rev robotics. And then it's going to be .spark. And then we're going to do a spark max. OK, and I'm tabbing basically to autocomplete these things. If you notice when I did some of the autocompletes, like, for example, spark, when I hit tab, there's an asterisk and it's highlighted. That asterisk is sort of like a wildcard. It means it's like it could be anything that is com.revrobotics.spark. Anything that's after that, the star would say include all of those things. But we just want to include one thing, so I'm just typing over that star and then doing spark max. You'll also notice that when I tab complete, sometimes it adds extra semicolons. The semicolon is a way in Java to sort of tell the computer, tell the robot that this is the end of code. This is the end of that line of code. Sorry. So if you have 3 of these, it's basically going to look at this and say, OK, you actually have this line of code and then 2 blank lines of code. It doesn't hurt anything. It just doesn't need to be there. So if you have extra semicolons, you can delete them. All right, so we we brought in the spark max. We imported our spark max. Let's do it again. And you know what? It's not an awful idea to copy up to revrobotics.spark. Because we're going to do a bunch of things that's all that. But I will do one more from scratch. So import com.revrobotics.spark. And then this one that we're going to add next is we essentially have some things that we can configure on each of these individual motors. And some of those things are, for example, we need one of the left motors to do whatever the other left motor does. We're actually going to have a left leader and a left follower, and we have to tell it to be a follower. Same thing for the right motor. We have the ability to set the current limits for our motors in the software here. We saw that when we were doing, in the last video, when we were using the Rev hardware client, we saw that you could kind of set the current limits there. It's better to do it here, just because then you're sure it's gonna show up. So in order to do all of those things, we need to import a bunch of sort of config-based options. So this first one that we're going to do is going to be config, just to create a config file. And it's going to be a spark max config. And yeah, I deleted a couple extra semicolons in the middle of that. We're also going to import. And then here's where I'm saying you can just paste that in if you got that copied, because really we're doing a few more of these. And this one is going to be we need spark low level, and then motor type. So remember there was brushed and brushless motor types. This way we can force to make sure it knows it's a brushed motor type and not a brushless motor type. You can paste again or type it all out again. So com.revrobotics, import com.revrobotics.spark. And then we're going to do spark base for this one. And then this is going to be persist mode. And one more. That's right, I had it pasted. Spark base dot reset mode. Spark base dot reset mode. Okay, so you should have 5 total com.revrobotics.spark things included here. And I'll leave a little space. And then let's do another import. This one will not be com.revrobotics.etc. This one is going to be, we're going to do a edu.wpi.first.wpilibj drive differential drive. So this is creating a drivetrain object so that we can control the entire robot's drivetrain as one thing. And I'll show you, we're going to do it without that first, and then we'll go back and use it. But I feel like if we knock out a bunch of these imports, then we don't have to come back up here and worry about stuff again. So we got that one. And then the last thing that we're going to use for our auto mode is one more import. This one is also edu.wpi.first.wpi-libj. And this one is just going to be timer with a capital T. So this timer is going to let us control how long we want stuff to run for in auto mode. So since we don't have any distance sensors or stuff like that on the default robot, we're going to have to tell it to drive forward for a certain amount of time and control our distance that way. All right. Next up, scroll down. We have public class robot extends timed robot. We've got our stuff here, our sendable chooser stuff. Let's see. And we've got this line, and then, yeah, I'm going to go underneath here. And we're going to just start making our things. So first thing, we're going to do private and final. It doesn't matter too much what those things mean for you, because it's not going to affect anything that we do. But private means this thing that we're making can only be accessed from within this class robot that extended the timed robot. If you have other files or other things running off in other places, it might not be able to access, these motors that we're creating here. So in this case, because we are doing everything in the one file, we can do private. That is theoretically the better way to do it, because you don't want things to be able to access things unless they need to. So private, and then final means it's not going to change. So when we say, hey, look, there is a motor. This is going to be our left drive motor, and it is connected to SparkMax with the CAN ID 1. That's never going to change the entire time our robot is running. So final means that's it. It's not going to change from that. So we're going to do final, and then we're going to do a SparkMax. So as I typing Spark, you want to find the one that says SparkMax. So we're basically is there an extra space here? Yes. It doesn't matter, by the way. Spaces are OK. I could put a bunch of spaces here, and it would work just fine. So it's just aesthetics when I add spaces. Well, you need at least one space, obviously. Otherwise, final SparkMax is not the same as final space SparkMax. OK. So we're going to make a new SparkMax. This is the type of thing we're making. So private final, the type of thing we're making, space. And then after the space, we're going to do the name of the thing. So this is going to be like left. I think first went with left leader. So this is our left drive, the leader motor. And it is equal to a new SparkMax. But this SparkMax, if it doesn't add it for you, we'll need an open and close parentheses afterwards. So we're making a thing that is a SparkMax called left leader, which is a brand new SparkMax that we're just setting up now. And inside the parentheses, it wants us to tell it what port it's connected to, which we said left is 1 and 2. So I'm going to do 1. And then you can see this in this pop-up too. It says, all right, what is the device ID? That is our CAN ID, which was 1, 2, 3, 4 for the drive motors, 5 for the roller motor. And then motor type and type. So we're going to do a comma. And if you remember, we created this motor type option up here. We imported this motor type option up here. And that was for this moment. And our motor type is going to be motor. That is not where I thought my mouse was. All right. After the comma, it's going to be motor type dot K brushed, because we have a brushed motor, not a brushless motor. And make sure you have a semicolon at the end of that line. Now, the other thing that I should have turned off, but you won't have it turned off, so maybe I shouldn't have turned it off. Right here where it says device ID colon in gray, I did not type that. You should not type that. It is adding that automatically. Okay? So if I go here and hit backspace, it's deleting the parentheses, not that device ID. That shows up on its own. That is a label where it's just saying it's device ID 1. It's just adding that label to explain what things are. So if you ever see that gray writing, do not type it. Just type the number 1. And here is where I was talking about spaces don't really matter. This still works. You don't need a space between the comma, but I'm adding a space there because I think it separates the things and makes it easier to see. All right, that was one of them. We're going to do it again. We're going to do it again a lot of times. So another private final spark max. This one is going to be our left follower. So one motor, we tell it what to do. The other motor just copies whatever the leader is doing. And that's still going to be a new spark max. Our other left motor, our left motors, remember, were in ports 1 and 2, or CAN IDs 1 and 2, so I'm going to put a 2 here. And then again, for motor type, it's trying to guess to fill stuff in here, and it put null. Null means it doesn't know. We're going to delete that, and we're going to do, again, motor type is .k brushed, and make sure there is a semicolon on the end of the line. That was the 2 left motors. Guess what? It's time to do the 2 right motors. Lines of code are going to look very similar. So again, you could copy and paste here. But we're going to do private final, spark max, right leader equals new spark max. Right was in ports 3 and 4, or IDs 3 and 4. So I'm going to choose 3. And then again, delete this null and do motor type .k brushed and a semicolon. And then, of course, we need private final spark max right follower equals new spark max. This will be 4. And this, again, is motor type .k brushed. All right, so these are our 4 drive motors. We're going to start with just the drive motors and get stuff working, but rest assured we will be back here to add in the roller motor and roller motor setup stuff when the time comes for that as well. Okay, next. We are going to then create our drive object here, which is going to start the same way, private final. And this one was called a differential drive. So up in our imports, we imported WPI live drive.differential drive. And it follows the same thing. So we're making a new differential drive. So you say the thing that it's going to be, which is a differential drive. Then you give it a name. I think you can just use drive. Maybe not, because like see, drive pops up as an autocomplete. So I'm afraid of using that because I don't want to use I don't want to name one of my things something that's already being used. So there are a few different ways you can get around that. You could do, I think sometimes there's this M underscore that shows up. I'm going to just call this one, this is my drive, and I'm going to capitalize the D. And that's going to be a new differential drive. And differential drive has the parentheses, and inside the parentheses, it wants us to tell it 2 things. It wants us to tell it what is the left motor of the drive and what is the right motor of the drive. And we're doing a differential drive. Differential drive basically refers to any robot where you're going to turn by running the wheels at different speeds. So kind of like a tank or like a lot of forklifts. You don't have steerable wheels on it, right? But it can still turn if you run one set of wheels forward and the other set backwards. That's going to cause it to rotate. And that whole class of maneuverability vehicles are called differential lead driven vehicles or differential drives. So our left motor, we know, is going to be our left leader, and that should show up as an autocomplete. Our right motor is going to show up as our right leader. And make sure you have a semicolon at the end of that line as well. So now we set up our drive. What else do we have to do here? I think we are good here for now. There are a couple of other things that we can set up here, and I'll show you how to do it. But for right now, just to get our first code off the ground and working, I think we're in good shape. OK, let's go down to public robot. And we've got the open close parentheses. We've got our sendable chooser stuff. I'm going to add an extra line in between. Blank lines, you can have as many blank lines as you want. I'm adding it just so that we can see the chooser stuff is up there. And then it's a blank line. I'm doing my stuff. I did the same thing here. It was like, here are all the spark maxes. Then I left a line and then did the differential drive. I just like to have it clustered that way. But you can add more spaces or not use the space if you don't want to. OK, so in this area, what we have to do now is do all of that configuration stuff. So this is kind of just like, it's a little tedious, but we have to do this to set up each of our motors with the current limit, and should it be inverted or not inverted? Should it be following another motor? Things like that. And we have the one. Oh, no, we didn't do that. We have to go back and create the one configuration that we can then use to set up all of our drive motors. And we're just going to use one configuration because most of it stays the same, and we'll just change the things that we need to change. So back up to the top, we're going to do one more private final okay, and this is going to be a Spark Max config. If you remember, we added that up here, Spark Max config, config.sparkmaxconfig. Okay, and we're going to call this one, this is our drive motor config, so I'm just going to call it drive config equals new Spark Max config. And for this one, we don't have to put anything inside the parentheses. Okay, but make sure you have the semicolon at the end. Now we're ready to start setting up our configs. So back down to where I was, I'm going to go leave myself one line underneath the sendable chooser stuff. And there are two things that we want all of our drive motors to always be set up for. And so the first one is we'll do drive config dot. So anytime we want to control something or work on something, it's always start with the name of the thing, which in this case is our drive config that we're creating. And then we'll do a dot, and then we'll pick the thing. So the first thing is smart current limit. So this is basically the maximum amount of current that the Spark Max or the motor can draw before it stops it. Now, there's a good chance if you don't put anything here, it's going to be fine. But turns out the more stuff you add to your robot, the more you want to be careful about not doing too much, drawing too much current at the same time. There are a few things that can happen if you draw too much current. One is there is a breaker for that motor. So if that breaker trips, that motor will stop working for a second or so while the breaker cools down and then resets. The other thing, though, is the main power switch on the robot is actually a 120 amp breaker. If you go over 120 amps for a given period of time, you could pop that breaker. And if that breaker goes, it does not reset. That would be the end of your match. Now, 120 amps is kind of a lie because it turns out you can do well in excess of 120 amps for short periods of time. I think you can do like easily double that for a few seconds. I don't remember what the actual chart is, but so don't get hung up on the fact that we have 4 drive motors, and if we add up all of our current limits, it's going to go over 120. The key is to limit how long it stays at these really high currents and to make it so that essentially we're not trying to pull too much at the same time. So for our smart current limit, we're going to set it to 60. And I know, like, right, so if you have 4 motors and they're all pulling 60 amps, that would be 240 amps. But it really only will hit this limit when basically when you are stopped and you slam it all the way forward and you start fully accelerating. That's the highest load on the motor. That only lasts for a short period of time, though. And then as the motor starts spinning, that current is going to drop down. So we're going to hit that stall limit only in very, very specific situations. And it's going to be for very short periods of time. All right, that's one thing. The other thing we're going to do is drive config dot. And we're going to do voltage compensation. And we're going to choose 12. And make sure you get a semicolon at the end of that line. Now, voltage compensation, if we don't do any voltage compensation, if we say, hey, send 6 volts or send half power to the motor, it's going to send whatever half of the maximum voltage of the battery is. So if the battery is at 12 volts, that means that it sends 6 volts. If the battery is at 13 volts, that means it'll send 6.5 volts. What the voltage compensation does is it tries to make it so that if you say send half the power to the motor, it's always going to be half of whatever our nominal voltage is. So it should be 6 volts. This is not going to have a big effect on your robot. So if you skip this, you probably wouldn't notice it. But what it will do is in autonomous mode, when we start the match, it will do a better job of keeping our driving consistent since we're relying on the voltage that we send to the motors and the time that we send it there. So it helps a little bit. We might as well do it since we're in here. All right, those are the 2 things that are going to be for every drive motor. But now we have to do something so I'll do a space. We have to do something that only needs to be done for one motor. So we're going to change this after we're done with it. So it's drive config dot, and we have the follow option. So remember, we have follower motors and leader motors. The follower motor just doesn't need any control. It just says whatever this other motor is doing, whatever my leader is doing, that's what I'm doing. I'm not going to think about it. I'm just going to copy what they're doing. So we have to set this up to where we're going to tell this motor to follow whatever we type in here. So let's start with left, leader. So if we send this config file now to our left follower motor, it'll know, OK, I got to follow the left leader motor. And in fact, that is the next line of code that we are going to do. So to configure a motor, we start with the name of the motor. So left follower dot, and it's going to be configure. And now it wants a few things. It wants to know what is the name of the configuration file, or the configuration, basically, yeah, file that we set up. And that is drive config, right? That's what we created with the current limit, with the voltage compensation, with saying follow the left leader. And then after that, we have reset mode and persist mode. And the reason why we needed to import these is so that we can type them in here. So we're going to do reset mode. I don't think I needed all of that. Let's try that again. Reset mode dot. And it's going to be k reset safe parameters. And it is, I was wondering why it didn't give me the option to autocomplete, because I spelled reset wrong. And there it shows up. OK, cool. Yep, so that's why you want to autocomplete. So basically, if the robot is reset, it can go back to safe parameters, basically a known, not going to be dangerous setup. And then it wants to know about persist mode here. So we're going to do persist mode dot. And this is going to sort of look the same. It's going to be k persist parameters. It's just saying, like, so the things that we told it to save, it's going to save. And those two things, the reset mode and persist mode, we're just putting that in every single one because that's part of the config and it wants to see it. All right, so that was our left follower motor is configured. We need to still configure our right follower, and then we need to configure our two leader motors here. So the right follower is going to be exactly the same as the left follower. So these two lines you could copy if you wanted to, with a couple changes. The first change is we do the drive config.follow. This time, we're not following the left leader, because this is the right follower. Obviously, we have to follow the right leader for the right side motor. And then the only thing that changes in the next line is its right follower that we are going to send the config file to. And of course, then it'll be configure. Drive config is correct. Our reset mode is, again, reset mode servo hub. You know what? There are two reset modes, and I keep tabbing. You want to tab on the bottom one. That's Spark base. Reset mode dot k reset safe parameters, and persist mode is it is persist mode dot k reset parameters. OK, our two follower motors are done. Now, we do have to set up our leader motors. So that means they need to no longer be a follower of anybody. So if we go into drive config dot, I think it's disable follower mode. Now, the next time we use this config, there is no follower. It's no longer going to follow left leader or right leader. It has no follower. It has to figure out its own path, its own way forward. And then it's going to be probably the same as the last line of code. Right follower dot configure. Drive config, yep. And then it is still all of this not changing, so you can paste that in, or you can retype it again. Okay, and then this configuration is good also for our left motor. So we're going to do left. Oh, wait. This should be right leader, because we already did right follower here. We're doing right leader, and then we have left leader dot configure, and the configuration for the left leader is exactly the same as for the right leader. They both get nothing to follow, and they both use the same stall limit and voltage compensation. So again, all of this is going to become reset mode, second one dot k reset, safe parameters, and persist mode dot k reset, k persist parameters. There we go. And a semicolon. Okay, now all 4 of our drive motors have gotten a configuration file. That is good. They're probably not all correct. We're probably going to kind of have to come back in here and make some changes, make one change at least, but let's find out what that change is and why it happens. So we're now ready to scroll down and start working on our first let's actually have a program do something. So scroll down to autonomous periodic. And we have K custom auto and K default auto. Default will run no matter if you select basically default or select anything that doesn't exist here. Default is sort of the catch-all, and it will run. And this is where we're going to put our test code. So our goal in this case is let's just make the robot move. If we can get the robot moving, like that's good. That's what we want to see. So I'm going to show you how to control a single individual motor first. So to control a single individual motor, well, in our case, if we tell the left leader to do something, the left follower is also going to do it. So we're actually going to control 2 motors. But we're just going to control the left side of our robot. So left leader dot, and if you want to control the output, you do set. And it says set, and you can see it's looking for what it says double speed inside the parentheses. Now, that doesn't mean that it's going to go twice the speed. In this case, double is a keyword for the type of number that it wants to see. So in programming, we have true and false, which is called Boolean. It can be true or false, 1 or 0. We have integers, which are whole numbers, 1, 2, 3, 4, and so on. Sometimes the integers can be negative, sometimes they can't. In Java, they can be negative, so it's fine. And then double, precision floating point number is what a double is short for. Double precision floating point number basically just means we can use decimals, and it tells us how big the number can be, how much memory the number can take up. So double speed is saying, give me the speed, give it to me as a double precision floating point number, which means you can use decimals, and 1 means full speed forward, 0 means stop, -1 means full speed reverse, and we can use any decimal in between them. So like 0.42 would be go 42% power forward. 425 would be go 42.5% power forward. That third digit may not really do much. So the first 2, yes. The third one, eh. The 4th digit, definitely not doing anything for you. Don't waste your time. All right. So in this case, let's just go forward. Let's go forward relatively slowly. How about 0.5? Go half speed forward. Now, I'm going to build this program, and while it's building, we're going to talk about why this is not the best of programs. So click on the WPI Live icon again, and we're going to choose deploy robot code one more time. If it's not there, remember start typing deploy, and it will show up. So this is going to build, and it is going to deploy. Now, this program that we have written never stops. It's going to drive forever and ever and ever. So I would recommend that if you were doing this, you put the robot up on blocks so the wheels can spin in the air and not crash into anything. Alternatively, I know how much space I have. I am comfortable knowing about how it's going to move with 0.5 power to that side. And I'm going to click the disable button pretty quickly after we start it and see it moving. So make sure you're ready for one of those two things. But we have a problem. So it says build failed in 8 seconds. If I scroll up to the top, if you ever get this problem, what you want to do is scroll up to the top and see what the error is. Now, the first thing that you would see if it were, for example, I typed something wrong. So I'm going to break this line of code right here. Left leader.set to this. And I'm going to deploy again just so I can show you what that looks like. The problem in this case, by the way, is I don't think it was a code error. I think it was a process error. OK, so if you see something like this, Java failed, and it basically says the file name, robot.java, and then gives you a line number, 103, and says cannot find symbol, there's something wrong on that line. So if I go to line 103, I can see, oh yeah, it's missing the dot in between the left leader and the dot set, or in the set. Sometimes, depending on what's missing, it might give you like the line before or the line after. So like if, for example, a semicolon is missing, it might give me the error on the next line of code because it thinks they're combined. So just like start at that line, but then look above and below it to see what's going on. Now, if I keep scrolling down, I'm going to see the other problem, which is resolved but not connected. It's trying to find my robot, which is 10.23.78.2, and it can't find it. And that's what that error means. Failed resolution, failed resolution. It kept trying, and then it gave up. Our problem is, remember how I switched to the wireless network to do the vendor lib and go online and download it? Turns out, we got to connect to the robot if we want to actually download code to the robot or deploy code to the robot. So make sure you are connected to your robot and not to the internet. So I'll click connect here. By the way, that is the first thing to check. Anytime it doesn't work, anytime you can't drive the robot, anytime you can't connect to the robot, anytime you can't deploy code to the robot, check the wireless network first. That is very likely the cause. All right, so we'll let that finish connecting. I think even when it's checking network requirements, I can probably deploy, but what the heck? We ain't got time to wait for that. I'm going to deploy the robot code again. Of course, if I was wrong and we did have to wait for all of that to finish, then I'm going to have to do this a second time, and that'll take longer than maybe just waiting the first time, but I'm pretty confident it's going to work. All right, there we go. Build successful. We got that box popping up, which is what we want to see. I'm going to close it because we don't need it. I'm going to open up our dashboard, our smart dashboard, and our driver station windows. Now remember, we put the code in default auto, so I'm going to select default auto. And then down here, I want to be on autonomous mode, and I will put some safety glasses on because when you're running the robot, you should be safe. And I am going to, it's easy for me because it's just a few people in this room, and nobody is in front of the robot, so I know it's safe for me to run it. But if you're running this in your workshop and you got lots of people, maybe somebody was fixing some zip ties on the robot and stuff like that, you got to look over, you got to make sure everybody knows you're about to start running the robot before you run the robot so that their hands aren't in somewhere unsafe. So I know my robot's clear. I'm going to get ready to enable, and then I'm going to click disable pretty quickly afterwards. So it's going to be enable, and then maybe a second or two, I'm going to click disable. I'm going to almost click disable as fast as I can. All right, so ready? We are enabling and disabling. I might have missed the button the first time. But we had space, and so I didn't worry about it too much. Or I would have hit the space bar. All right, so a couple things happened there. One of them I forgot was going to happen, and that is I expected the robot to go, right? We ran the left motor, and it started going this way, right? So that was the left side of the robot going backwards. But in the code, it says set 0.5. So I expected that left motor to go forwards, which is one of the things that caught me off guard here. I expected the robot to go not backwards, but to go forwards this way. That's what I was looking for. So that means our left motors are backwards, which makes sense. Actually, one of the motors has to be backwards. One of the sides of the drive has to be backwards because our motors are not facing the same way in the robot. One's facing this way, one's facing this way. So clockwise for this one when you flip it over to this side, is going to be going the opposite direction. So we knew we were going to have to flip one, and we already learned it was the left side. So that was cool. But the key here is our robot worked. It moved. We were able to control the left drivetrain. And now we can start fixing stuff and start working on an actual autonomous mode. So let's scroll up to the top here. Maybe not quite the top. Remember where we did all the configure stuff? Find the line that says left leader.configure, and we need to be one line above that. And essentially, every time the left motor does something, every time we send a power to the left motor, we send it 1, we actually meant -1. If we send it 0.5, we meant -0.5. Now, we could, in the code, every time instead of typing 0.5, we could type -0.5. That would fix the problem. It would work, but it would be confusing because -0.5 on one motor and 0.5 on the other motor shouldn't mean drive straight forward, but that's what it would mean in that case. So we want to make sure that things make sense when we're looking at it. So we want to essentially flip the sign, and we can do that by, we could multiply it by -1 all the time, but again, we can fix it up here. If we do drive config dot, and then I believe it is, I think it's something inverted. Yep, just inverted. Perfect. And then inside of here, it put in is autonomous, which is like a wild guess that has nothing to do with this. So if you see that, don't be confused. That is VS Code trying to be helpful and completely missing. All we need to put inside here is true or false. Should this motor be inverted? In this case, yes, true. But true with lowercase t. Okay, make sure there is a semicolon on the end of that line. Now, that should always make that motor go in the opposite direction. So once again, we still have 0.5 down here for the speed we're setting it to. I am going to deploy this code again. I'm going to give myself a little bit more of a like a angle because we know it's going to spiral back towards me. And once it's done building, all right, our new code, good. We got the pop-up. That means we're good. Going to go back to our driver station and our smart dashboard. Still default auto, good. Autonomous mode. Again, so I'm going to click enable, and then I'm going to, again, pretty quickly click disable, but hopefully it moves forward this time. Ready? And enable. And disable. That was forward. That was exactly what we wanted to see. All right, let's reset this robot. OK, now, in the code, we could, to drive straight forward, instead of just doing left leader.set, we could then also add right leader.set, 0.5. And this would make the robot drive straight forward because we'd be sending 50% power to both sides of the drive. But we're going to switch over now. Instead of controlling the motors individually, we have that drivetrain that we created. And that's going to let us do all of the code on one line. So I'm actually going to delete what we did. That was just for testing. That was just to get stuff going. And if you remember, we created a, what did we call it? A My Drive. And we configured that to have the left and right motors already set into it. All right, so down here, if instead we do My Drive dot, and there are two main choices for control here. There is arcade drive. Arcade drive basically is going to ask for a forward and backwards power, and then it's going to ask for a turning power separately. Or we could do tank drive. Tank drive is going to ask for what power do you want to send to the left and what power do you want to send to the right. I personally, for auto mode, prefer tank drive, and for driver control for teleop mode, I like arcade drive. So that's the way I'm going to do it, but just know that you can make either of them work. So we're going to do mydrive.tankDrive. And this is what I was saying. It's asking now for left and right. What power to the left side, what power to the right side. And this kdefault period, that's just guessing again, and it's just guessing wrong. Those have nothing to do with what we're doing. All we're going to do is put numbers in here. If we want to drive forward at 50% power, we do 0.5 for the left side and 0.5 for the right side. One more thing I'm going to mention while we're at it right here is, by the way, if you make one negative, that label disappears. So remember this gray that's showing up? That is a label. I didn't type that. It's adding it for me. Don't type it. It will add it for you as well. except if you do a negative number. If you do a negative number, it doesn't add the label. It only does it for positive numbers. That's fine. Don't worry about it. That works. All right, but 0.5, we should now be able to have the robot drive straight forward. Let's go ahead and test that out. So we're going to, once again, choose the WPI Live icon and choose Deploy Robot Code. And we're waiting for that pop-up to know that it's finished. All right, perfect. Load our things up. All right, we're still in default autonomous. All right, I'm going to enable. I know there's a light eventually that it's going to crash into, so I'm going to try to stop it before it crashes into the light. All right, here we go. Enable and disable. That drove pretty much straightforward. That's what we wanted to see. All right, so that's working. We know how to make our robot drive forward. Let's do one more quick example of, backwards is pretty obvious, I think. It's just a negative number there. Let's do another example, though, of turning in place. Most of the time when we go out to drive with the robot, we want it to, there are lots of ways we can do it. So, for example, if we use the robot and we say, OK, this motor, we saw it with just the left motor driving. Like, if just one side drives, it sort of rotates in a pretty big circle. That works. We can also say, hey, maybe the left side is 0.5 and the right side is 0.2. It's going to be an even bigger arc that it drives on. And you can sort of control whatever you want that arc to be. But the field is crowded. And so typically the best way to make turns is to turn exactly in place. So you don't need any extra room to make that turn. So then if there are other things in the way, other robots in the way, you don't have to worry about hitting them. So in this case, in the code, instead of doing 0.5 and 0.5, if we want to turn in place, I'm going to change one of these to a negative number. So like if left is 0.5 and right is negative 0.5, what does that mean? That means the left side of our robot will go forward. The right side will go backwards. That means we're going to turn to the right, or we're going to turn clockwise. So let's see if that works. Let's go ahead and hit the button. Choose Deploy Robot Code. Looks like it's working. OK, and every time before I click Enable, I'm always asking myself, all right, what should happen with what we just changed? What are we testing? And in this case, I want to see the robot rotating to the right, but basically spinning in place. So let's find out if it does that. I'm going to go ahead and enable it now. That is spinning to the right and basically staying in place. Let's disable it. Pretty close to straight. Slightly early. OK, so that works. So now we know how to turn. If we want to turn the other way, obviously we make the left side negative and the right side positive. OK. We're now ready to start creating our auto mode. And that means we have to figure out what our auto mode is going to do. And you have lots of options. So first thing is you are on a starting line. And I believe it's any part of your robot has to just be over the starting line. But you should double check the rules just in case I read them wrong. So if your robot leaves the starting line, like if you drive pretty much at all, during auto mode, you'll leave the starting line, you'll get 3 points. But beyond that, if all 3 of the robots drive off the starting line, you can get an extra ranking point. Ranking points are really important. So basically, when you get to an event, you're going to play 12 matches with random partners and random opponents. And in each of those matches, if you win, I think you get 2 ranking points. If you lose, you get 0. If you tie, I think you get 1 if there are ties. If you have all 3 robots leaving the starting line, you get 1 more ranking point. That is the same as a tie. That's half a win worth of points just for having all 3 robots leave. So if you can do that in all 12 of your matches, you're going to get basically the equivalent of 6 wins worth of points for your ranking. That's huge. You definitely want to be able to do that. Also, there's another way to get a ranking point as well, but that involves gameplay during driver mode, so we don't care about that for autonomous. OK, so we know we have to be able to drive forward off the line. We can start with that program and get that one working. And then we also start with one of the coral pieces in the robot. And if you score a coral piece on the shelf on the lowest level on the reef, that is worth 2 points if you do it in driver control, but 3 points if you do it in autonomous mode. And you might think, okay, so it's worth one more point. It barely seems worth it. But also, don't forget, if you score it in autonomous mode, you don't have to spend any time in driver control mode scoring it. You're already starting on your next piece. So it's worth one extra point, but it's worth like 10 extra seconds of time. So that's also pretty huge. So I think ultimately we're going to want to do an auto mode that can drive forward and spit the coral out onto the reef, get that 1 point on that shelf there, and get that 3 points for driving, 3 points for spitting it out, and the potential for that extra ranking point. Now, the reef area, right, is a big hexagon, and we have a starting line, and we got to figure out how far the lines are. There are some drawings that are available that you want to find is the 2025 Field Layout and Marking document. And that has some dimensions here. So let me go ahead and recreate. Like, obviously, if you have access to a field, go to that field, do your testing there. We don't have a field yet. We just have this carpeted area in the room. So it's nice if you have at least carpet, but we're going to sort of lay out some lines to visualize where things are. Then we can write an autonomous mode that will work between those lines to get stuff going. So first thing is I'm just going to kind of push the robot out of the way. And I'm just going to do one random line in a random place. And this is going to be our starting line. So we'll put our starting line, I don't know, somewhere around here. And that's probably enough starting line for me. You might need, more. You might want more of an area for your starting line, depending on, how deep you're getting into auto mode. So driving straight forward and dumping it off is great, but you might need to have one where you start off to the side and have to turn in and come to the side. Okay, then if I look at this, the shelf or the edge of the reef where we can start scoring for the straight forward of the hex is 88 inches away from the line. I think it's from the edge of the line. So we will operate under that assumption. So if I start measuring out from here, make sure we're on that line there. Good. Okay. So 88 inches is right here. Okay, and then actually I can sort of make this the right size of the hexagon too. So the hex is not labeled here. Okay. But it is 93.5 minus 2/14. So 93.5 minus 14 is is 79.5 minus 14 is 65.5. So if this is 65.5 long, that's about the size of one side of the hexagon. Turns out 65.5 is pretty far. 65.5, so it's about here. So this is about the length of one side of the reef. And it should be at 88 inches. So we'll put the very front of this at 88 inches. Didn't know I needed that much room. All right. So that's at 88. And that seems pretty good. Okay. It's pretty close, pretty close. Let's now sort of reset our robot here. And grab one of our coral pieces. Remember, you get to start with one of these preloaded in the robot. And again, you should be double checking all of this, but I think you can start with any part of the robot on the line. There's no like you have to be in the middle of your robot or anything like that. I think if your bumper is over the line, it counts. But you get to basically choose, where do you want to start? Do you want to start like, so your wheels are lined up on the line? Do you want to start so that the edge of the bumper is lined up? My suggestion to you is to pick something that is easy to line up visually. So, the back of the bumper being over the edge of the line is something that might work. Trying to line it up so that the frame, like maybe if you look at the side, you can see exactly where the frame is. Or possibly, and this is farther back, but you could line it up so that if you look underneath, the wheel is just right on the edge of the line. And that might be the sort of best to be repeatable with. So if both wheels are right on the line, then you're sort of set up right. But it doesn't really matter what you choose. It could be the front of the robot. That said, we have to drive that way. So if you start way further back, that's kind of a waste of time. And so now, if we think about what our auto mode should do, the auto mode should, at the very beginning of the match, drive forward until we basically get to this line. And this line is a wall, right? We're gonna hit it, and it's not going to move. So we can drive to this line, but if we drive a little bit too far, that's not really the end of the world, because we're going to just drive in and then try to push for an extra little bit and then still be right up against it. One of the things that we don't want to do is if we drive in really fast, it might bounce off the wall. So if you drive in really fast, but you're coasting when you hit the wall, you might bounce off. So it's better to have that last bit under control when you drive up. Then once we're driven up and we're kind of settled against it and we're making sure that we're pushing against it, then we want to turn the rollers on to spit out the piece. So our first step in this auto mode is to just figure out how to drive forward to the line and then stop. So I'm going to bring this back again. I'm going to sort of line it up as best I can so the wheels are right on the edge of the line. Seems good. And if we go back to our code, we have a couple of things that we're going to have to add. The first thing is right now we have no way to actually control how long things are driving for. So scroll all the way back up to the top. Remember we added this timer, import timer, but we never created one and we never used it. That's the next thing we have to do. So if you find the class robot extends timed robot section, we're going to do a new line underneath our drive config, SparkMax config, drive config. We're going to do a private final. This is a timer. I'm going to call it timer 1. Maybe you're going to want a second timer for something else later. It's a new timer. And this just needs a semicolon. It doesn't need anything on the inside of it. So now we have a timer that we can use anytime we want. And this timer will be like a stopwatch. And anytime we look at it, it will tell us how long it's been since the timer started. We can also reset the timer. But basically, this will let us say, OK, drive forward until the stopwatch says 3 seconds, and then stop. And then spit out the coral piece until the timer says 5 seconds, and then stop everything. All right, so inside here, we have to do a couple more things. So we created the timer. Next thing is, in this public robot area, this sort of like runs right away when the robot starts. And I want to make sure our timer is started here. So we can do it anywhere we want. I'm going to do it. I guess I'll just add it on the bottom. It doesn't really matter where it ends up. So we're going to do timer1.start. OK, so this starts our timer, our stopwatch. And then if you scroll down, in autonomous init, because we're going to use this for autonomous, we want to make sure that it's at 0 when autonomous starts running. So inside here, we're going to do timer1.restart. That will reset the timer. And the reason why I'm not just putting timer1.start here is because if we use the same timer, or if you end up using the same timer in teleoperated mode, when you're practicing and you just go straight to teleoperated mode, it would never get started, and so it wouldn't work, right? So by starting it at the very beginning of the program and then just restarting it when we needed to go back to 0, that's sort of the safest way to do it. So now in auto mode, let's delete this. So default right now is do nothing. We're going to want to change the name of some of our auto modes. So actually, let's scroll up to almost the top. So we have these lines of code here, which is private static final string, kdefault auto, kcustom auto. These are the names of our auto modes. If you want to add more, you basically just copy this whole line of code, paste it, and then create a new one with a new name. My auto doesn't really help for me. I'm going to do center. So we're going straight at, we're starting in the center, going straight at the reef. And we can center, let's call it center plus coral. Center and coral. So now on that menu where it said like my auto and kdefault auto, we'll have center and coral. We might have center and just drive, or we might have one that says just drive to get off the line and you don't score the coral. Maybe the coral thing is not working. You might need one that starts out on the right-hand side, goes forward and turns in, or goes on a long diagonal into the side. And you might have one for the left-hand side. So you could have center, left, right, and just drive, and don't move at all as your 5 potential auto modes. We're not going to work all of them out with you, but we are going to get this center and coral one working for sure. So I changed the name here. We need to scroll down, and inside robot, we're adding the option, and this is the name that's going to show up. So instead of my auto, again, we want this to be center. Whoops, I undid too far. All right, so this my auto here, we want to change this to center and coral. And then the name of it, instead of calling it kcustom auto, I'm going to call it k center coral. And I guess we'll do the capital letters. And I think did I miss one more spot? Yes, here. Instead of kcustom auto, it's going to be k center coral. Okay, so that line where we did center and coral, you have to call it k center coral equals center and coral. And the quotes is just, that's the display name. And then down here, we're loading it as an option, center and coral. And then down here, where we choose the auto mode, this case is going to be k center coral. So if we choose k center coral, we run the code here. And I'm going to get rid of this comment because it doesn't really help us at all. All right, then for k center coral, what do we say? We said there's going to be a few steps. So I can leave some notes. Our steps are going to be, first thing is drive forward to the reef, and then reef. And then step 2 is going to be stop and like deposit the coral. So we really only have 2 steps for this auto mode. Step 3, in this case, is going to be stop everything. And that step 3 is going to be the last step for all of our auto modes. No matter what our auto mode is, the last step is going to be turn everything off. OK, so now we need to use the timer to decide which of these steps we're on. So look at the stopwatch. If the stopwatch is at 0 seconds, we're definitely in drive forward mode. And it's going to stay drive forward mode until the stopwatch gets to some number. And we can check that. In the code, we say if timer1.get. So timer1.get basically just means read the stopwatch value. And if the stopwatch value is less than, how long do you think it takes to drive that far? Let's try 3 seconds. I don't know, 3 seconds. If it's less than 3, so that means if the stopwatch reads any number less than 3, 1 second, 2 seconds, 2.5 seconds, whatever, until it gets to 3 seconds, we run the code inside these curly braces. And that code is going to be drive forward, which we control by typing the name of our drive, what we called our drive, which is my drive dot. And then, remember, I like tank drive for auto mode, tank drive. And then what power do you want to send to the two motors? Now, when you're picking speeds for auto mode, you could go full speed, but we don't have to. If you're only driving forward and scoring one coral, we got lots of time. We got 15 seconds to make it happen. And the faster you go, sometimes the less accurate it's going to be. Also, the slower you go, the less accurate it could be. So you want to, be somewhere in the middle, I don't know, half, 25 to 75%. Is where it is going to be typically the most accurate. So given that, let's just go 0.5 and 0.5. I usually like to start slow too. And then if you keep adding stuff to your auto mode and you're running out of time, then you can go back and start speeding stuff up to try to make your timings. OK, so until 3 seconds happens, we drive. Then our next step, this is else if. So first it checks the first if. If the stopwatch is less than 3, do this. If it's not, let's see if this next thing is true. And this next thing is going to be timer1.get. Again, everything is going to be timer1.get. And we're going to say, is it less than? And the question is, how much time do we think it takes to spit out a coral piece? I don't know. 1 second, maybe 2 seconds. Let's give it 2 seconds to spit out the coral piece. So I can't put a 2 here. Because if I put a 2 here, that is never going to happen. Because if it's less than 3, it runs this. If it's less than 2, it's also less than 3. So this number here needs to be 2 seconds added on to when the previous step ended. So the previous step ends at 3 seconds. That means this one needs to be 5 seconds. So this case will run, everything inside these curly braces will run between 3 seconds and 5 seconds. And in this case, we're going to turn our drive off. So my drive dot tank drive 0 and 0. OK, then we need to be able to turn our roller on. So that is something we're going to have to work on. Let's do the last case. The last case isn't going to make super sense right now, but it will later. The last case is else. And else basically says, if none of the other things are true, if nothing else is true, run this. This is it. We always run this if there's nothing else to do. And in this case, we want to make sure everything is turned off. Now, it turns out our drive is already turned off, so that's cool. That's not a big deal. Really, we need this to turn off our roller to stop spitting the coral out. So that said, it still makes the most sense for us to turn everything off and just always have an everything off thing. So this line of code that turns the drive off, we're just going to keep that here too. So it doesn't help right now, but if you imagine there was an auto mode where the last thing you were doing is driving. Let's say after you dump the coral off, you wanted to start trying to drive over to load another piece of coral. Well, if you were driving at the end of auto mode and you want to stop moving, you get to the last case, you want to make sure that your drive is off. So when you go to add more steps, if you try to add more steps, you're always going to go above the final else case and add another else if. So we could do another else if timer1.get is less than 8 seconds. So now we have 3 more seconds where we could be, maybe backing up, and then we could turn, and then we could drive somewhere else on the field. But we're sticking with a very simple one first. So I'm going to get rid of that. And this is good enough for us to test, because we haven't set up our roller motor yet. We're going to set that up. But let's see if this lets the robot drive forward and stop, on the line. So I'm going to go ahead and deploy that code. And one of the things is I'm not rushing to add the roller in yet, because when you're working on auto modes like this, it usually helps to make one step perfect before you move, or really good before you move on to the next step, because they can all affect each other potentially. Like the timer could change. If I have to change the time that we drive forward, but 2 seconds was perfect for spitting out the coral, I got to change all the numbers in order for the new driving time to work out. All right, we are set up. We are deployed. We are going to now enable it, but you'll notice when I load this, we have default auto, and now we have center and coral. So I'm going to choose center and coral because that is the new one that we just created. I'm in autonomous, good. I'm going to enable it. And in this case, I don't have to disable. I'm not going to disable. I'm going to let it run until it stops on its own. That is the 3 seconds of driving. Unless, of course, it looks like it's going to crash into something, in which case I will click disable. All right, here we go. 3, 2, 1, enable. Okay, that drove too far, definitely too far. I want to say it stopped driving about here and then coasted. So we went about a full robot width too far. Let's reset this up. We needed to drive forward 88 inches minus 1 robot width. And we drove plus 1 robot width. So we drove 88 inches, and we needed to drive about 58 inches. So that is about a third too long. So let's go back in here, and let's take the 3, and let's try making it a 2. And then we're going to deploy and try again. And this whole process is just me choosing different numbers until it works out right. And I'm going to also grab, it's not going to be perfect, but I'm going to grab my gray crate here, and I'm going to put that right on the edge of this line so that the robot will at least have some resistance when it gets to the end. And maybe I'll take a couple of these bolt bins, because they're kind of heavy, to give it a little bit more resistance to moving. Because remember, we will have a solid wall that we're driving into. So if we drive too far, it should, kind of stop and help hold us in place. All right, we are updated. It is downloaded. So I'm going to go back now, still on center and coral, and enable. Here we go. OK, that's not bad. With the resistance of the thing we were driving into, we drove forward, I want to say about 4 inches too far. So we're close. Let's line this up again. I'll fix the bin after we start deploying the code. So in the code, 2 seconds was just a little bit too long. I don't know. Let's try 1.8, 1.9, 1.8. 1.85? It's probably not worth thinking about that much. It's probably better just pick a number and go for it. So we're going to deploy that. I'll fix the bin while that's happening. All right, build successful. And let's give it another go. And enable. I think that's perfect. It did hit and it did push a little bit, but I was basically listening, and from the time it hit it to the time that it stopped driving was very, very minimal. So let me do one more test here. And now that I know, I've watched the robot, I know what it's going to do, I feel like I can probably go and stand behind the crate and make sure the crate doesn't slide out of the way. Because the field, it's a giant, huge thing. It's not going to move much when you bump into it. And we're not hitting it very fast. So don't do this unless you're very comfortable with what the robot's going to do. If you have more weight, you could try stacking more weight, or even adding Velcro to the bottom of the crate. But this time, I'm going to race the robot. So I'll disable. And then I'm going to re-enable. And then I'm going to try to get to the other side of the robot and hold the crate so we can see what happens when the crate doesn't move. So 3, 2, 1, go. OK, so that is interesting. It did bounce off. We're about an inch away. I don't know if that's a problem. We can fix that by slowing down, or we could fix that maybe by driving forward, doing this drive, and then creeping forward afterwards, adding another step of driving. But when I was holding the bins, there was almost no impact. It was really stopping really close to the right spot. So I actually like this. I think we'll stop there for the driving. That feels tuned in enough. Obviously, we're going to try to take it over to a real field or a bigger field with a built-up reef that we can test it on if we're able to. So let's now go back and let's add the ability for us to then spit out the coral after it gets there. So might as well reset it while we're here. And back to our code. Now, unfortunately, we got to do all the setup stuff for the roller motor as well. So let's get back up to the top. Do we need anything new at the top? We don't need anything new import-wise. So head down to class robot extends timed robot. And I'm going to put it, I guess I'm going to put it above the drive, because I'm going to create another Spark Max here. So I'll do private final, right? The line above Spark Max left leader spark, because we're doing the same thing. This is going to be a Spark Max. This is going to be our roller motor. Again, you can call it whatever you want. That is just its name. It is a new Spark Max. And our roller was in port 5. And the type is once again K brushed. And make sure you have a semicolon. I didn't mention this before, I don't think, but you'll notice that sometimes we get the yellow squiggly. The yellow squiggly is not the red squiggly. The yellow squiggly means that we created this roller motor thing and we never used it. It's just telling you, you might be wasting your time with this. The code will still run fine though. So if you see yellow squigglies, don't worry. They're not breaking anything. Red is the bad one. Okay, so we created it. Next, we have to do the config for it. So in here, I guess above timer.start, just so we can stay with the other config stuff. I'm going to go in and I am going to, oh wait, no, hold on, timeout, go back up. Right here, underneath our SparkMax config for the drive config, we now need to make a roller config file. So we're going to basically do the same line of code, private final SparkMax config, and this is going to be our roller config equals new SparkMax config and a semicolon. Okay, now we can set up that config and send it to the motor, or the motor controller technically. All right, so back down where I said where our configs are getting set up and whatnot. And we're going to do roller config, right? We start with the name of the thing we're starting to work with, which is roller config dot. And let's do our current limit, smart current limit. And I'm good with 60 on this one too. Sim motors and 60 is a pretty good number. Okay, and we just keep going. Next is roller config dot, and this is going to be our voltage compensation. Let's do 10 volts on this one. It never needs really the full amount of voltage, so having a number that is going to be consistent is more important for us. And even though our battery starts at 12 point something when it's fully charged up, the longer you go into a match as you're driving around, the voltage is going to drop. If you're driving and you're rolling the rollers at the same time, the drive motors are going to actually, like when you run motors, the voltage will dip because the motors are basically pulling a bunch of current out. So you'll see a dip there. So going down to 10 volts should give us a little bit more consistent control, and we never need 12 volts, so that's fine. All right, what else do we have to set up on our roller here? You know what? I think that's it. That seems good to me. So let's do the name of the motor, which is roller motor dot. And then we're going to configure it. And we're going to use roller config, not drive config for this one, because it is the roller. And then these other things are going to be the same. So reset mode, second one, dot K reset safe. And persist mode is going to be persist mode dot K persist parameters. And make sure you have a semicolon. All right, so now our roller motor exists as roller motor, and we have our config set for it. So now we can go all the way back down to autonomous mode. And in this else if, we turn our drive off, but also this is the mode where we want to turn our rollers on. And in fact, let's see, I can do the labels, instead of having the labels up front, it can be this is drive to the reef. This is stop moving and spit out coral. And this is end of auto, turn everything off. All right. So to spit out the coral, how are we going to do this? Well, choose the motor that we want to control, which is roller motor. dot set. And then we just give it the power that we want the power to be set to. OK, the set was mad just because I didn't put a number in yet. OK, just checking. All right, now, here's the thing. We don't want to go 1 power. We don't want to spit it out super hard, because that has a chance of bouncing off the shelf and not staying in place. And we're going to use the number that we want to put here every time we're depositing the coral. If we have auto mode 1, we're going to use the number. And the number that is the first recommended number for starters is 0.44. So I could type in 0.44. But then if I do another auto mode, I have to type in 0.44 there. I do a third auto mode, I have to type in 0.44 there. I do teleoperated mode, I have to type in 0.44 there. I have 0.44 in a bunch of different places in the program. Then we get to the field, we find out that, hey, ours is actually not 0.44. For whatever reason, our motor is a little bit stronger than the default motor that first used when they tested it. And my number is actually 0.40. 0.44 makes it bounce out sometimes. Well, I don't want to go through and find all the places I typed 0.44 and change it, because it's too easy to miss one on accident. And this is a very important number. So instead of typing a number in here, we're going to create a variable that we can use to adjust that number later. So if you go scroll up to the top, not quite the top, scroll up to where we did the config for our roller motor. And I think that's a good place for it. That makes sense to me. Does it? Yeah, let's go up higher. Let's go where we did all the private finals. That seems like the best place. All right, so I'm going to do underneath timer, private final timer. I'm going to hit enter a couple times, and I'm going to create now a variable that we can use, that we can store that number in. So this can still also be a private final. It is going to be a double, because remember, it's a double precision floating point number, means we can use decimals. And we now get to name it. Now, convention, when you create these constants like this that are not going to change, the convention is to make their name all capitals. So I'm going to do that, but know that you don't have to if you don't want to. All right, so this one is going to be called roller underscore eject underscore value equals 0.44 and a semicolon to end the line. Now, if everywhere I say roller.set 0.44, I use roller eject value, then if we find out this roller eject value is not the right value, this is the only line of code we have to change. We just change the number here, and it will fix itself everywhere else in the program. So let's look at that. If we scroll down now to our autonomous, this is where we do roller.set. And if I do roller eject value, wait, what? That is not where I thought the mouse or the redo that. Why? There we go. All right, we're back. OK, I don't know. It was typing down here. I clicked in the wrong place. All right, so inside the set, we do roller eject value. There it is. OK, and that's what we're going to put in there. But roller eject value literally just means 0.44. OK, so now we had 1.85, and our guess was about 2 seconds to spit the thing out. So this 5 would be very excessive. Let's dial that back to 2 seconds, which would be 3.85. And let's see. Of course, 2 seconds might not be enough. I don't know. We're going to find out. Let's deploy this code. And I am not going to race the robot this time. That was way too much effort. That was stressful. We're going to let it bounce off. We know it's going to drive a little bit too far. That's fine. I'm not worried about it. So now, once again, I'm asking myself, what should the robot do? It should drive forward. It should stop. It should bump and then go a little bit past the line we know, et cetera. And then after that, it should start spitting out the coral piece for 2 seconds, and then everything should turn off. So let's see what happens. And 3, 2, 1, enable. I didn't click. Enable. And I'm going to disable. mistakes were made. There were a few mistakes. Let me bring this back and load it up. There are a few things that I want to change now that I've seen that happen. And those things are, number one, you will have noticed that the roller never turned off. That is because we never turned it off. All right, so in the code, this last line where I said this is where we turn everything off, but I never turned the roller off here. So let's do roller motor dot set 0. Now we are actually turning the roller motor off. Now, the other thing that I saw, which was a little bit of an issue, was like as soon as we hit that wall, it was spitting the coral out. And that could work, but I find that if the robot is like bouncing off the wall at the same time that it's spitting out the coral piece, it might not be as consistent. So what I want to do is I want to say step 1 is still drive there, but I'm going to add a new step 2. And step 2 is going to be just chill for a second. Let everything settle, then spit the coral out, then stop everything. So let's add that extra step in here. So first step, good. Second step, I'm going to go underneath the first step and do a new else if. And the else if, it's still going to be timer1.get. If it's less than, let's settle for 1.15 seconds. So that would mean 3. If it's less than 3, then we're going to do this. And this is just turning off the drivetrain. So my drive.tank drive 0 and 0. Okay. So now for the first 1.85 seconds we drive forward. Then for the next 1.15 seconds, between 1.85 and 3, we turn the motors off. Then from 3 to we have to adjust this number. I think it felt like 2 seconds was too long, but there's not really a lot of danger in running the roller extra. So I'm going to leave it at 2 seconds just to make, because the worst thing would be if it didn't spit out, right? In fact, maybe I'm going to make it 2.5 seconds. I'm going to do 5.5. Because if the roller is just spinning a little bit longer, nothing's going to hit the roller. It's not in the way. The robot's not driving somewhere, blocking things or crashing into stuff. So that seems fine. And then we have our turn everything off. I think that's it. Let us deploy the code. And while it's deploying, I'm going to make sure I'm on the line nicely. And I'll take the bin back to the line here. And our deploy is finished. So I'm going to go ahead and pop up my driver station. And yeah, let's go. 3, 2, 1, enable. Now it's chilling. And now it's spitting it out. And then it stopped. OK, yes. That 2.5 seconds, way too long. It was spinning for a while after it spit it out. In fact, it was spinning for so long, I was like, did I forget to turn it off again? But I like that. Like I said, I do not want that roller to, or that coral piece, that PVC pipe, to be stuck in the robot. So extra spinning there is OK. Probably you could trim it down a little bit. Perfect. This auto mode is working about as well as we can get it working on our test setup here. Now, just remember, when you get to a field, or if you can get to a field for practice, you should go there and you should test your auto modes there. But even if you do that, when you get to a competition, you're going to need to tweak some of your auto mode values on the actual field. You might have to drive a little bit farther, a little bit less far. It just depends. When they build the field, there's a tolerance to it. When I did the taping here, there's a tolerance to it. When you visit somebody's practice field, there's a tolerance to that as well. So nothing is going to be exactly where you expect it to be. Be prepared to make adjustments and be prepared to make continuing adjustments. If your motors at the end of the season are a little bit worn out, you might need to drive forward a little bit longer to get to the same position. Probably you won't run into that problem too badly, but it can happen that way. So that is one auto mode kind of done and in the bag. Let's do one more. We're going to do the simplest auto mode just so I can show you how to add a second auto mode in here. And then we'll talk about the other auto modes that you might want to think about. And that should do it for this video. So I'm going to go ahead and reset the robot. And reset the crate. Go get that coral piece, bring it back. Now, I'm going to do an easy auto mode. And that is, so there are a few things that might happen. You might be paired with robots that can do literally everything in auto mode. And for them, because the loading stations and the extra coral pieces on the field are accessible from the outsides, they probably will want you to start in the middle. So you can just drive forward, spit yours off, and not get in their way. And they can go to the sides, score, and then maybe try to get more pieces. Now, if you want to try to score and get more pieces, which is great, and if you have time, I definitely recommend doing it, then you might not want to start directly in front of the thing. You might want to start off to the side, in which case you'll have to drive forward, turn, and then drive forward in and spit it out, and then back up, and then turn and go try to load another one. Or I think if you start far enough out, you can drive straight in on a diagonal, but you'll have to check that. So that would be a longer drive. That would take longer. But it's possible that you have people that have only the same auto modes that you have. Like maybe you only have straight and to the right, and you have two teammates who do the exact same thing, and they're like, we can't change ours. And so you need one that just is safe, that just gets you the points for leaving the line, but doesn't spit the coral out because maybe you're not going to be in a position to spit the coral out. Or maybe something is wrong with your auto mode, it's not driving the right amount, and like wasting that coral piece to score it in auto mode is not worth it. Like if you can score it, it's worth it, but if you might miss, if it's like a 20% chance of making it, it's probably better to keep it in the robot. So let's go ahead and make a safe auto mode, which is drive only, just to get off the line so you can guarantee those 3 points and hopefully the ranking point. So in the code, what we have to do is kind of jump all the way back up to the public robot section. And if you remember, we have default auto. Our default auto right now is do nothing, so that is an option. But let's add a brand new one. Let's add a brand new one, which is only drive. Okay, so after the first one, or after the last one here, after center and coral, and the order that we put these here is the order that they will show up on that dashboard screen. So if you care about the order, you can do that in the order that you want. But the first one has to be set default option, and then the additional ones are going to be add option. So we're going to do m_chooser dot add option. And then we're going to do the name, which is, quote, this is just drive, end quote. And we're going to call it k just drive. And of course, it doesn't know what k just drive is. So we have to scroll up. I forgot this part, public class robot extends timed robot. And underneath center and coral, we're going to do private static final string. So just like what's there. K just drive equals, quote, just drive. And you want to make sure these two lines match. So this and this should match between those two lines. I think if I did it in the other order, this one would have auto-completed for me for sure. OK, so we created this new option. We added it to the dashboard. And then down here, it can pick it. And if it's picked, then we need to create a case down here for it. So we have default auto here, which is going to run if nothing else is correct, and that there's nothing there, so that's our do nothing auto. We have our center coral auto. And basically, a switch basically says, read whatever is in auto selected, which are those different text things. If it's k center coral, do this. If it's default auto, do that. Well, that's easy then. We can go at the end of the break, so we're just on the line above k default auto, and we can type case. And this one is k just drive. And you end this line not with a semicolon, but with a regular colon. And I'm going to hit enter twice. And I'm going to do a tab, and then I'm going to type break with a semicolon. So for the switches, it's everything between the semicolon and the break is what's part of that case structure. So instead of the curly braces. And I also did the tab. The tab is just to show you sort of like what's included in stuff. So if you look up here, for example, autonomous periodic, there is a switch, which is inside autonomous periodic, so it's tabbed in. And then there is the K-center coral, which is part of the switch, so it's tabbed in again. You can use the tabs just to help see the code a little better. And in this case, we just want to drive forward, and we don't want to drive that far forward. So this is just going to be an if timer1.get is less than, and I would say we are starting right on the edge of the line. So we probably don't even have to drive a full second to get off the line. Let's do like half of what we were doing in the other case. So let's do 0.9 and see how that looks. So if it's less than 0.9, then we want to be driving forward. So we're going to do basically the same line of code, my drive dot tank drive, 0.5 and 0.5. We'll still go half speed. And then we need our turn everything off. This is the end of auto mode case. So underneath this, since there's no other steps, our steps for this are drive forward and stop, then we can just go right to our else case. And we do my drive dot tank drive 0 and 0. So now we should have created a second auto mode that will only drive forward a little bit and then stop. Let's deploy it and let's see if it's showing up on our dashboard and if we can choose it and if the auto mode does what we want it to do. All right, looks good. Let's load up our driver station. Now here on the dashboard, look at our smart dashboard. We have default auto, we have center and coral, and we have just drive now. So that's perfect, that worked. I'm gonna select just drive, make sure I'm in autonomous, and then we're gonna run this one. And again, I'm thinking before I run it, I want the robot to drive forward to like here and stop. Let's see if it does it. Enable. Yeah, okay. That might be a little too far because we have the extra coasting going on, but essentially I didn't want to crash into anything. I wanted to go so I'm definitely comfortably clear of the line and have the potential to stay out of the way of our teammates or just protect the coral if for some reason the rest of our auto mode is not working correctly. So that I would say is working exactly the way we want it to work. Now, if you don't like how far forward this one drove, I'm going to disable just to be safe. Before I start talking. Now, if you don't like how far that robot drove forward, if you want it to drive a little bit farther back, so if you're like, you know what, I'm very comfortable if it stopped like here over the line, adjust that number. We did 0.9, go ahead and make it 0.5. I don't need 0.6, whatever gets you to the distance you want. You could slow the robot down too. You could make it go 0.4 instead. I will add that when you're trying to dial in a specific distance, changing the speed will not be a linear adjustment. So if I did 1 power to both motors and said drive for 2 seconds. If I then said do 0.5 power to both motors and drive for the same amount of time, it will not go half as far. It's not a linear relationship there. So the best way to tune values in is to pick the speed you want and then just adjust the time. Don't adjust the speed and the time. That can make it really, really hard to sort of dial into a good working number. So again, here, because we're just creeping forward off the line, you could start with the slower speed and then dial the number in, or you could just cut the number in half. It drove about twice as far as it needed to. Cut the number in half, that's fine. All right, we've got 2 working auto modes. Technically, we have 3 working auto modes because we have a do nothing auto mode if we don't even trust the driving, if there's something really messed up with the robot and we don't want to move in auto mode at all. So we've got don't do anything, just drive forward, drive straight forward, and dump the coral off. There are 2 more auto modes I think you should work on. One is coming in from the left and dumping it off, and one is coming in from the right and dumping it off. And if you get all 5 of those auto modes working, and you still have time and your programmers are ready to go, then you know what? I think you can human load in auto mode. So if you come in from the right, spit out the coral, back up a little bit, and turn so you're facing the human player, drive all the way over to the loading station, they can drop another one in. And you know what? Even if you don't get all the way there, driving closer to the human loader, to the loading station, there's a good chance that's the first thing you're going to want to do during the match anyway. So just driving there saves you some time. If you can load it, but you can't get back and score it, that also saves you some time. So that's great as well. So you want to just start adding to it. And the way that you should do the auto modes is a lot like this robot, is get the basic ones working and then iterate up to more and more complicated ones until you run out of time. And by iterating up in complexity, if you run out of time and the event is tomorrow, you don't have nothing. You didn't start with the hardest auto mode and have nothing that works. You have a bunch of working ones that you were building and creating more functionality into. All right, we are done with auto modes for this robot. We're going to come back in the next video and we're going to work on driver controlled or teleoperated programs. But before we go, we're going to give another special thanks to Argosy for making this all possible, to First and Andymark for parts and support, and to Team 302 Lake Orion High School for hosting our studio.